All right. Hello, everyone. Thank you for joining us on Thursday, May 1st, which is the day before my birthday. Let me just put that out there. It is 1 p.m. Eastern Time, and we have Steve Borosh here. He's going to be talking to us about exploring ClickOnce and .NET hijacking for SSH initial access. That is a mouthful.
Woo.
Yes. All right, Steve, take it away, buddy.
Hey, thank you very much, Deb. A little bit about me. My name is Steve Borosh. I have been at Black Hills Information Security for almost 4 years now as a security analyst, penetration tester, red teamer, and instructor through anti-siphon. So got here about 4 years ago by way of TrustWave Government Solutions and a few other places that I've been throughout my career, which started in 2014, really. I finished my degree in network security and immediately got hired because I posted some code on GitHub that tied in a tool called Armitage, which was the precursor to Cobalt Strike, and Veil Evasion Framework, which took your shell code that you would create and made it bypass antivirus and things like that to give you an executable or DLL or whatever. So shellcode manipulator. Merged the two together in Raphael Mudge's Sleep language, which was fun as a young coder. And I put that together, posted 30 lines of code on GitHub, and a couple days later, I got basically like, hey, are you interested in working for us? A message on IRC, Internet Relay Chat, to go work at Verus Group. So that was 2014. I packed up my stuff and went and lived near DC and started working as a contractor for Homeland Security. So that kind of started my cybersecurity career back then. But I really do enjoy teaching. So a lot of times since then, I've taught at Black Hat and DEF CON, gave a bunch of red team workshops at DEF CON a couple of years ago. Teach for private Fortune 500 companies overseas, taught in Poland last fall. That was a very fun course on offensive operations against foreign adversaries. So that was fun. And generally just like sharing my knowledge and giving the things that I create back out because, hey, it got me into the industry, right? Putting my stuff on GitHub immediately got me into the industry. So I'm big on that. Whatever you create, whether it's a simple script or something like I make today that I just released for initial access, whatever it is, put it on GitHub, put a gist, even if it's a simple script or something. I get emails and messages all the time over the years about people like, hey, I found this thing you made and like it came in really handy for me. And it's like, yo, I never even really used that. I made it on this one op, did it, posted it, and that was it. So you never know that somebody else might learn from it, benefit from it, whatever, or you could use it again. So post your stuff out there. And let's see here. Screen's freezing 1 second. Reshare here. There we go. Okay, so what is the purpose and scope of this specific webcast? So over the course of my offensive security history, we've had multiple ways of getting into organizations via phishing, Teams messages, direct exploitation to things. But, ever since probably about 2016, 17, really the perimeter switched from the firewall at the border to whatever cloud service you're now connected to as well. Any services,
Can you zoom
really.
that in a little bit?
Sure. So initial access has always been like a pain point for operators and like a really key part of that. Michael Allen teaches initial access course through Anti-Siphon right now. I would check that out if you get a chance. The guy pulls some really cool stuff out of his sleeves to get access into companies. And I had one, but I basically put it out the pasture because Microsoft changed so many things that it was heavy in. That it was just too much to keep up with. So I don't do those courses anymore, but check those out from Michael Allen. So getting into C2, like getting command and control, has always been important. And now we can do like token theft or, adversary in the middle where we're stealing somebody's credentials and reusing them across like Azure or wherever the company uses things. And so there's a constant battle against those things. And I like to revisit older techniques and kind of, see what's new and what we can invest some time in to make older things work just as well as they used to, or even better. So I've also been part of a lot of assumed compromises. And in those assumed compromises, I like to establish an SSH tunnel out of the organization to come back into the organization and proxy my tools and traffic and things like that. And many organizations will tell you, we don't allow SSH out, you'll never get out, blah, blah, blah. We do protocol inspection, this, that, or the other. And then I found out that it was almost always a way to get out, regardless of what they said they could block for SSH. And Microsoft, a few years ago, decided to put SSH on every Windows PC. Windows 10 passed a certain patch point, and Windows 11 now. It comes with OpenSSH. It has the connection, the keygen bits, all that kind of stuff. What it does not have by default is the server, SSHD, or the daemon server. But that's installable. If you go to the features and things in Windows, you can add the SSH server if you want to have an SSH server. So I'm always thinking about living off the land and things like that. But I've also noticed that defensive products like EDRs would catch on to me renaming binaries. So if I would rename whatever, like command prompt or PowerShell or MS build, like rename it from that to another file name on the system, like totally legit.exe, it would know that you renamed it and then flag on that. So I started bringing my own instead of, renaming something on the system. And so on one engagement, I brought my own SSH client, my own OpenSSH, and I ran it. And the only signature that I got from my client was an SSH connection was detected outbound, and the process was killed. But I noticed in the results that it was ssh.exe that was being called. So I was like, okay, well, if I rename it, it's going to detect that. But what if I bring my own and it's already renamed? What if I'm calling that SSH string from another binary name? So I did that against one of the top EDRs, and it a couple of years ago, about a year ago, because I've included this method was in my enterprise attack initial access class for years to get the initial access, but I was always launching shellcode from it. And I just was always wondering, well, what else can we do with the ClickOnce before anything else happens on the system that we could use to get out of the system or into the system more stealthily? So SSH being an option for that, I started creating a payload for that, and noticed that if I connect back out, I can then also bring my own SSHD.exe or SSH daemon server, right? So I can run my own server as the user's context in the context of their Windows environment. And with my reverse tunnel, I can connect back into my own SSH server right on the system as that user. So now I don't even have like the proxy and then like authenticate to anything. I'm already authenticated with a shell as the user, which we'll see when I go through my demo and everything. So that gives us, once the payload is executed, that gives us a reverse tunnel with SOX capabilities and a shell as the user, which we can type PowerShell or whatever prompt we want, and then change whatever we want. So we're literally on a shell as the user, SSH into a Windows box. And then I ran this today against Sentinel-1. Typical detections did not fire, nothing fired actually. And I'll show you a lot of the things that I did to get around that. And today was the first time I had even tested it against EDR since I made this. So a lot of things come into play there. Static, brittle signatures, right? A lot of EDRs will say they're doing the next gen, whatever behavioral analysis, but it comes down to like, does this match that? And a lot of those times we can break that with timestamps, file names, and all that kind of stuff. So you have to think about every chain in that detection process. Try to keep it as simple as possible, keep away from the static signatures, and typically you can get around most things. So I tell you that because I'm going to deploy this. It's already on my GitHub, and you can go look at it now. If I can get to the tab here. But it is at reverse shell, bolt hole, and if somebody wants to throw that into chat, I would appreciate it. But this is public now. instructions on how to do it, and I'll walk you through all this here in a moment as well. We're using things like .NET configuration side loading. So we're going to use exe.config to sideload our ClickOnce DLL that we generate, or the DLL that actually launches SSH and all that stuff. So, and then I tell you how you can SSH back in from your server back into this. It does port detection, so it'll try multiple ports, and you can modify that in the code. I'll tell you about that. So it's not just, hey, can I SSH out over 22? Because that was my original thing. I had companies blocking that. And then I also had companies checking, port 443 for protocol inspection, protocol matching. And that has been detected before. So, but then if I go from a protocol that is supposed to be SSL to like 31337 ephemeral high port, doesn't get detected. Same thing if you do DNS. If you configure your server to accept SSH connections over DNS, port 53, you're going to have a lot more success too, because really not many places, I haven't seen one yet, detect over protocol inspection for port 53. They just say, hey, let's TCP DNS. Okay, cool. So we'll come back to that in a bit. But I do want to give shout outs to some previous work and kind of give an overview real quick of what ClickOnce applications are. So ClickOnces, they're not actually click once. In this case, with a self-signed certificate, it's going to be 3 clicks to get your code execution. So we'll see that. If you have a legit signed certificate, that's 2 clicks really. So the benefits of ClickOnce is that it's self-updating. There's multiple formats. So it's not just DLL or EXEs. There's Windows Presentation Foundation. So there's all these other different static detection points that many of these things might only be looking for DLLs or EXEs. What if there's something else? What if you make a Windows Form application versus a console application? How does that look for EDR? Self-updating, you can have it check for newer versions and things like that. You can have it install persistence, all kinds of stuff you can do. ClickOnce applications are self-contained, so they won't break other software installs. They literally go to a random app data. If you go to local app data, apps, apps/2.0, that's where your app gets stored. There's a data folder, and then there's a random string folder. Your apps are in there. So they don't actually get out to system level or whatever. Now, ClickOnce applications, you can actually have them try to elevate with UAC. And if the user has it, they have it. If they don't, then it'll just continue as is. So that's a possibility too. You can try for admin access, but that's also another potential detection point and or warning to the user, like, hey, this thing's trying to do admin stuff and I don't have admin access. What does IT expect me to do here? And then it causes trouble. So prior research, so standing on the shoulders of giants. 2012, actually, Zscaler released 2 blog posts covering the topic of abusing ClickOnce applications. So the first one was stolen code signing certificates are your worst nightmares. So this one was highlighting the effect, like if you have a signed ClickOnce, it shows up green like this. Now, this is the old school, looks a little different now, but basically it's trusted, right? So you clicked on it on the web page, which then opened this, and then you click install. So there's 2 clicks with a correct signed certificate. If not, then there's 3, and then 4 if you're doing UAC. So they went through that, and then another blog post similarly, but a little bit more on like, hey, like how to detect it. Simple stuff, but not too intensive of a blog. So, but then we come to NetSpy. NetSpy in 2015 came up with all you need is a ClickOnce love story. This was a great blog that really spurred it for us on the offensive teams to where we started using ClickOnces on our engagements. And this is really good read as far as like how it actually all works. My blog post isn't going to go into like what the manifest does and like where the reg keys are and all that kind of stuff. You want to go that deep dive, get into this NetSpy post and follow this along. It's really, really well put together and tells you all the bits, all the parts, all the files you need, all that kind of stuff. Web server, but instead of using, here they're talking about veil payloads. Yeah, so this is a case of a ClickOnce launching, shellcode in a way, right? It's launching Veil, which is going to do whatever your Veil payload was. Typically, that was, command and control with Meterpreter, Metasploit, or something like that, Cobalt Strike. All right, so that's a good read. Make sure you check that out. This is kind of what the ClickOnce looks like when you go to the web page. It will, let me see if I can pop that up over here. Show that later. So when we go to the web page, it'll actually be like an install link. Now you can inject JavaScript or whatever to like automatically download whatever your ClickOnce is and run it. But I don't do that. I give like a fancy little what you call it, splash page, like an IT splash page. I'll show you. All right. So we have those as far as previous research is concerned. So shout out to all of them for that. And then use cases. So like I said, the most common use case is shellcode loading, right? Launch Cobalt Strike, launch some kind of C2 or whatever. So I wanted to take it away from that. And like, how could we gain access to this system and then regain access to it easily and things like that, which is little hurdles as possible. So using something that's already on the system, maybe bringing something along ourselves that wouldn't get as detected. So I like to use like VPN portals, things like that. I'll clone a company's VPN portal. I'll say, hey, your VPN software needs to be updated. And then the portal will drop the file, or they'll click the application link, and then the ClickOnce will fire off. I like to use Azure websites, and I'll give you the commands to do that. AZ web app up. It's super simple. You can launch an HTML application super easy, but you do have to be cognizant of the web config file. So I'll show you here in the web deploy folder. For Bolthole, there is a web config, and this web config explains the MIME types. So we'll see those here. So a lot of these you want to be just plain text because you don't want any processing done of that. We just want to get the file and read it with our .NET application. So that's what the web config is for there. We could have it launch VPN. I mean, literally, you're launching .NET code on a target Windows system. You could do anything the user could in that .NET code. So that's kind of, I think, what I want to show next is go through that. Let me stop the share here, and then we'll pick back up in Visual Studio. Any questions I can answer while I'm switching over? Anything burning from chat? If not, no worries. All good. All right. So this is the actual ClickOnce application. This is Bolthole. This is the C program, or C# program, I'm sorry, that basically uses app domain injection to load our code. So this will get processed and built as a DLL, not an EXE. DLL is still an executable, but we're going to use a configuration file along with a known Microsoft binary called perfwatson2. It's just a binary that's in Visual Studio 2022 or whatever. It's in all the Visual Studios. So literally all you got to do is copy that perfwatson2 exe, put it into the web deploy folder, the web deploy folder. And then when they click on that application, the ClickOnce will actually load this DLL because the config loads it, right? So you can change these if you want, right? Rename the classes, rename the functions and things like that. If you're looking to obfuscate this for yourself, I'm sure detections will start coming rather quickly for the default stuff. So keep that in mind. For the most part, you can change the app domain, you can change the classes. Like here, check ports is one you could change. And what we do is we actually loop through a set of ports, and we check to see what we can connect out to, right? And if we can't connect out to any of these, we drop it. And the ones we can connect to, we add to a list. There's some more extensibility I need to do with this proof of concept to like actually go from one to the next, I think. But you can see here, if we can't get out on 22, then we go to 443, then we go to 80, and then just 31337 custom port I threw in there. So all of those have to be listening then on your SSH server. I like to use Azure Virtual Private Servers or Azure VMs to do mine because you get a fully qualified domain name like this. So this is for Azure, East US 2, wherever the region is, cloudapp.azure.com. So to see that come out of the network as a network call, a DNS network and a network call versus just going to straight dotted quads is one less detection point. And the fact that it's Microsoft and Azure, a little bit more credibility to being a legit application or whatever service out there. And you can name it like your client name, whatever, the website or the VM can be FQDN, can be whatever you can name it in Azure that's not already taken. So if that's like some kind of doppelganger for your client, that's great, because then if the SOC analyst, and I've literally seen this, they look through the logs, go, oh, that's ours. That just the name's in it. It's got to be ours. So you can match some of the infrastructure of your client organization and try to use similar things like that, just as another layer of obfuscation. So we loop through and then we check the ports. And how do we check the ports? That's up here. It's just an asynchronous call. So not a SYN scan. We're trying to asynchronously connect using .NET. I would have thought that I would be getting all kinds of like, hey, you're trying to scan outbound, EDR alerts. Nothing with this type of connection scan. So far, so good there. So the things you got to add in here, your server that you're going to call back to, that your target is going to SSH reverse tunnel back to, wherever that's VPS is. Like I said, use the FQDN if you can. Change and add whatever ports you want. If you think there's different ports that may be allowed out of your client network, go for it. Do that here. But then remember, on the Azure VM side, you have to change the Azure firewall to allow all of these ports inbound TCP to those ports. All right. And then here is where the DLL will actually start doing the SSH stuff. So what I did was, originally, I used to have this like secure copy. A good thing about secure copy on Microsoft Windows is that it does not leave mark of the web. So if we copy something down from our payload server, there's no additional mark of the web on that file. So what I was doing was using SCP to copy down the SSHD file, the SSHD config file, the authorized keys file, all that stuff. And then I got wise. I was like, why am I making all these extra connections when I can bring all that stuff with me in the payload? So we create this DLL. We're going to put this into another web deploy folder that we use Azure websites and the AZ web app up command for Azure CLI to actually deploy the whole package to Azure in one command. We don't have to do anything. We just, whoop, there it goes. There's our website. It's weaponized and ready to go. Super easy. There's no like Nginx config or Apache config or anything to do like that. So what this is doing here is, when this launches on the target system, it's going to go to that random local app data folder, right? So I don't know where that is. It's just randomized. So I could, and I originally did, have all these files go to like C Windows tasks, because C Windows tasks is globally readable and writable. But it's also now a good detection point for malware, because we've all been using it for so long. So then I thought, well, let's just bring all that stuff with us in the ClickOnce application, already renamed. So look here, I have boltd.exe. That's sshd.exe, just renamed. And so I did that for all of the files. And be sure to rename yours, right? Because you don't want the same static signatures I have on my GitHub to go into your environments or whatnot. Change them, they're super easy. And then we launch SSHD or boltd, right? We tell it where the config files are. And that literally launches SSHD in the form of boltd.exe. So EDRs are like, hey, there's no SSH daemon running. when in fact it is, because brittle signatures, static signatures are bad. And that's what most of these EDRs and XDRs are doing. Even though they do have, yes, some great tie things together, human behavior things. This isn't one of them. So then we want to get that reverse connection out. So now we do bolt con, which is actually ssh.exe. And then we give it flags, right? We don't want to check the host key. You know, you SSH into something. It's like, do you want to accept this host key? Yes or no. So we automatically do that. We set some timeout values, compression, so that our stream is better. No forwarding agent. We're keeping the stream as minimal as possible to keep it alive. TCP keep alive, yes. No logging errors, all that kind of stuff. And then later on in the string, you can see we take those variables, the open ports. So where's the first one of those open ports? This is where you can start iterating through, like, hey, if port 22 was open, but then when I actually try to get out and it doesn't let me, try port 443 or try port 80. This doesn't have that logic built in yet. It will be soon. But if you need to do it on your own, this is where you would do that. We give it the bolt key. So on the target system, we're leaving a private key into your server. Haha, yes, keep that in mind. So in the documentation for the bolt deployment, there is a string how to make a user, right? So in Ubuntu, you can make a user that has no shell, restrict it, lock it down. So you'll see the user's computer connect back to you via SSH with no shell. So keep that in mind. If you need to further restrict that or whatever, but this tunnel has to come back to you so you can get back to it. So what I do is I do a reverse port forward, SOCKS proxy type 9052. And then I also do this. So port 31332 is actually the port that SSHD or boltd is listening on the user's local host, 127.0.0.1, 31332. Now we have an SSH tunnel coming out. Then when we come back in, if we SSH to 31332 on localhost on our VPS, we get to the SSH tunnel and get right into the SSH shell as that user on the Windows system with no password. Why? Because we have an authorized key, we have an authorized keys file, and the SSH deconfig that we're calling right here has password set to no and has pub key set to yes. So we just SSH directly from our VPS right into the target user system, and now we have a shell as that user, which we'll show. So then, you know, all of this, you could take out all the bits that might, you know, probably don't need to write line, anything like that. Some further obfuscation can be done and whatnot. But that is bolt holes code. And I kind of want to show you some more here. Okay, so in my web deploy directory, let's see, here we go. So bolt hole program, or the project, looks like this in this folder here. We have the SLN, which is, you know, the Visual Studio solution, the README, our license, and all that stuff. Basically says use it, but don't abuse it. Bolt hole, which is the program itself. And then when you build it, this is the debug, but when you build it in release, that's where it'll show up, is in that bin file. So we build it, and then we copy the DLL and the config back over to the web deploy folder and the install folder. Now, this is where you're going to have your bolt hole DLL and DLL.config. You're also going to have your application and application.manifest. And I think I can show you one that's probably... already done. Yeah. So when you run through the directions, you'll create a self-signed signing certificate, the ClickOnce CER, private key, and the PVK. So you'll have this stuff to actually sign the application with a self-signed certificate. And we'll see what that looks like. It's better than nothing, but again, at the end of the day, it's like one extra click because you don't have that self-sign. And if you have an EV cert, I believe that's even better. But in the web deploy folder, we have what you see here. It's the configuration for the portal that you'll see, the web config that I showed you, and the install folder, which has the bolt hole DLL and config, assigning stuff, and then the installer and the manifest that you create along with it. So when we actually build this, you'll see I opened a developer console. So if you go into tools, command line, developer PowerShell in Visual Studio, you'll get to that prompt. It's a developer prompt. And then you navigate to your install folder. This is where we would first create our application manifest here. So we'll call it installer, and you can name this whatever you want. The to file here. Let's see if I can make this bigger. Enhance. Yes. So exe.manifest is what we're going to create first. We're calling it perf watson 2 because that's the name of the executable. The version, which matches that of the executable, if you right click it. Full trust. And you can actually do UAC and stuff here too, but we're not going to do that. And then from the current directory. So we do that, and then it creates the manifest. And then we sign the manifest. Yeah. And then we create the deployment. That's the installer application, and that points to your application, right? And then we sign that as well. And once we have all that stuff signed, then we can go into here and actually deploy it. So AZ web app up, location ECUS2, blah, 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 blah. And then whatever you want to name it, that subdomain comes here. So I want you to see what all that looks like. I can do watch netstat -tulpn. I'm going to grep for 31332 because that's the port that I'm forwarding back on, one of them. I have the local app data folder here, so we should see the random stuff being made. All right. So here we go. We're watching on our server. I'm going to download and install the mandatory update. So this is the first prompt we get. Open this file. Now you could actually, send the link directly to this file to somebody. You can even do this for lateral movement if you wanted to. You can copy this over to another system and execute it, get your call back. So we're going to go ahead and hit open. There we go. So there's our random folder and the data folder and app data. And this is where, if you had a correct signed certificate, see the name installer, we created that name. So that is something that you can create based on your client name, IT department, whatever. Publisher is unknown, right? Because of the way we did it. But if your pretext is correct, whatever phishing you're doing or whatever, maybe even this website says, you'll see a warning on this, please click run, blah, 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 don't call IT. So I'm going to hit run there. And we see the size 4.4. I'm over satellite, so I'm a little slower, but. Now we have bolt D, that's the SSH daemon kickoff. And bolt con, that's our reverse connection that went up there. Let me see if I get, yep. So 31332 is calling back. So then I should be able to SSH back into the target system. Oh, that's the wrong one there. Right here. User. And then we're going to talk about some stuff here in a second. So I have EDCSA, and that pub key is on the client's target machine because now it was in the applications install folder, right? I'll close that. So if I connect back in, you see down here another bolt D popped open as a child process. And now I'm that user in a shell. This is a command shell, so it's not a PowerShell. So if I type ls, not recognizable, but bada boom, bada bing. Now I'm in PowerShell. So just like you were on that system as that user, I have a prompt. I even have their PowerShell profile showing up for me here. Same colors and everything. So now we have, and if I just tip exit, right, that's going to take me back to the CMD, type exit again. We should see that one bolt process exit, but the main bolt process still continues, and we still have access into that system. So now we have maintained until the system reboots at this point. We could do a few more things to set persistence for this application, a scheduled task, or there's, I think, a few things in the ClickOnce you can do to make it like continuously run and check itself, right? Just, do I still have a connection? That kind of thing. Hey, look at all the emojis. Yeah. Woohoo, demo worked. Sweet. So that gives us, and if I want to go right back in, boom, I can. Or if I want to proxy like Impacket or other tools, I now have a SOX proxy through there. I'm not going to curl because that's my IP address we're working on there, but yeah. So that's basically the ClickOnce and how that works. Now I want to show a couple things here real quick. If I were to, there you go. Watch auth log, right? And rep for user from, oops, might actually have to do that properly. It's not recent enough. So in the code, and I don't have it in there right now, but I'll add it as an option. There is a way to first do a connection as the current user's environment variable. So basically what we do is we do a connection, same thing. We copy this exact same string, but instead of username being our user to SSH back to, it's going to be the environment variable for the current user. So back in the SSH logs, we're going to first get a failed attempt for me, that was user. Username is user on this system, right? I'm on. So yeah, user at risk. So if you're looking at the auth logs, you'll see a failure coming from your target as the username to user or whatever it is in that environment variable. Now you know what user to SSH back into, because if you're just sitting here and you didn't get that in the auth log, how do I know who I'm authenticating as, right? I don't know that user's name unless you just do from whatever recon or whatever you do before, then you don't have to add that bit. But that's a good technique. My amigo Gabriel from Black Hills taught me, was that first SSH with the user's user in the environment variable. And I'll add that stuff, I think, to the next iteration of this tool. But yeah, that's pretty much it as far as the tool and concept and all that stuff. I think we can probably open up for questions and whatnot here soon. And also I want to point you all to my blogs, my wonderful blogs at Black Hills Information Security. Right here, category author Steve Borosh. So this is where my next blog, which has this and everything about it, will be posted hopefully in the next week. I have been procrastinating profusely on getting a blog post done, but it is almost done. And now that we've done the webinar, good to go to get that pushed out. So an actual write-up on all this and everything we talked about will be on the Black Hills blog soon enough.
Well done, Steve.
What's the second reverse port? Thank you. So I'm looking at questions and they're the second reverse port 9052. So that's a good question. So in the code, I have this. You don't actually have to have that if you do SOX proxy like this. So instead of here, I would just add D dash, 90 or 1080 or whatever I wanted my SOX proxy into that network to be. So you can do it this way, or if you do it the way that I did it, then you can do like a local port forward over that and point your proxy tool or whatever at the local point forward, which will take it through the reverse port forward. All the forwards of the portings. Thanks, Roxana. Good question.
Yeah, there were a lot of questions, Steve. Yeah. And I would say if you could just ask them again, if we missed it in Discord or if we missed it in Zoom, if you could just ask it again, then Steve can see it. And
Yeah, I can see Zoom. I can't see, or I can see Discord. I can't see Zoom right now.
Zoom, gotcha. Okay.
Similar to using Beef? No. So Beef is it's basically like a webhook framework to hook somebody's browser. So here where I showed you like browsing to my site, if I had Beef running on the back end of this site, it would basically hook your browser, let me see what you're doing in that tab. I could do specific things, data enumeration, maybe some exploitation, cross-site scripting, stuff like that. But this is not that, not similar to Beef. Chad comes out with a good question. How to detect SSH traffic on weird ports? Possible with heuristics or some other analysis. So usually that's up to the vendor of whatever product you're using for protocol inspection, right? So protocol inspection is basically like the technique to say like, hey, this packet has this header. Does it match what this port is typically used for? But that's kind of a wide range of possible areas to get around in my book. So protocol inspection is the best place to start there. And then also I even think just looking at like Windows firewall rules from the system itself, outbound allowed. Do your users need to go out on all these ports and stuff? I don't know. You might be able to restrict it a little bit more there. The ephemeral ports are where that becomes hard because things just open ports, right? So if I just use an ephemeral port, it's probably going to be allowed out. So protocol inspection kind of comes from there, yeah. Another question, does the DLL and bolt hole tool require read, write, execute permissions? I'm wondering if an EDR can detect execute activity initiated by the DLL. So the DLL isn't what's actually being executed, isn't doing the execution. It's additional things like Rundle 32 that kick off the actual DLL load. So that's where to look for. And I don't know if you even see that here. You would see that when the ClickOnce launches. But the EDR we test against always detects our DLL loads for ClickOnce is using Rundle 32. In my case, it did not with this payload. Not 100% sure why there yet. Yeah, there's some good signing things if you want. Yeah, Secret Squirrel, Seek Thief. I used that a lot before. Good stuff. And then I think I released a timestamp. Did I? Thought I did.
Here's a pretty simple question. How do you defend against this?
Yep. Same thing. You watch our webinars, you read my blogs, and you follow along in your own environments and tune your things to match what we're doing. Just like everything else, you got to try, test, and practice. Otherwise, you don't know if it will work. We're talking about that a little bit here. Protocol inspection, the main thing we're looking at from out of the network for the SSH configurations, because we can rename ssh.exe to whatever we want, right? So that that kind of makes that a little bit more difficult, but blocking outbound ports that don't need to be blocked, that, and then DLL loads from like ClickOnce applications. So image loads basically from like Rundle 32 that then maybe call out to the internet would be good as a detection point. ClickOnce applications that aren't correctly signed, you can just should be able to write out block those in your environment. Or if they're not signed by you, right? If your organization doesn't sign it, or it's not part of a package of software or whatever that you use, you should be able to deny that.
Good job, Steve. A lot of questions coming in. If you have
SSH disabled by anyone but admins. We use threat locker requiring users to send a request if any unknown file or DLL tries to load or execute. That's good. Yeah, allow listing. Those kinds of restrictions are great. Yeah, taking SSH off the system in the first place is a good start. But like in this case with the ClickOnce, I bring it along with me, renamed already. So that's another thing to think about. Yeah, we're burning LOL bins real fast in 2025. Yeah, of course. I mean, I think everything's an LOL bin now, right? Everything can be used for some sort of initial access almost. Yeah, and then so another thing that I started doing, oh, this is a very good point. Yes. If you like to use command and control, Cobalt Strike, Empire, any of those things, Brute Retell, and you can use this as your initial access vector, let's say. And back here in the code, oops. Oh, did I just hit stop share?
you're sharing Discord now.
What?
No, that's me.
That's you? Then you hit stop sharing and it's just Brian.
Hang on. Coming back. All right. Yes. So very good point here. So this is our connection, let's say, from the target host back to us. So let's say we did a reverse port forward for 8080. 8080. And now when we create our Brute Retell or Cobalt Strike shellcode for this target system, we have it point to 127.0.0.1, 8080. And then basically what you can do is you could forward that to your Brute Retell server. You could have Brute Retell running on this or wherever else. I've done multiple hops. You could say like, hey, forward this over to another IP address actually, and then forward it on to your actual C2 host. So what that does is your command and control no longer calls out to the internet. It calls out over your SSH tunnel, which is already encapsulated. So why call out to the internet when you've already got a tunnel? SSH tunnels are like the best thing you can have in a network. You can even upgrade this to a VPN. There's a few commands you can do to do that. Especially now that we have our own server in the environment using the SSHD. So all kinds of stuff you can do with this now as far as other implementations of using the tools that you usually use, command and control, in packet, things like that. Packet 50 time.
You're monitoring the Discord. Do you want me to ask you the questions or are you just going to take
I'm looking. Have you changed the strings and hash? The latest MDE detects the app domain hijack technique. Are you experiencing any alerts? I have not tested against MDE specifically. Yeah, change the strings, change the hash, match app domains that already exist, maybe on the current system. You can do that. Turn it on, turn it off.
There was one question up. It says the latest MDE detects the app domain hijack technique.
That's what I just talked about. Yeah. So basically, I haven't tested against that. You have to test it. But again, you can change the strings and you can also try to match things already on the system. If you already know app domains that exist on the system, you can try to blend in with those.
Got them all, friend.
Sweet.
Yeah, we'll wrap up a little early. Steve, do you want, if you could sum up everything, one final thought with Steve, what would it be?
One final thought, keep tabs on Black Hills Information Security and all of our anti-siphon trainings and blog posts, because the things that we do on our engagements are the things that come out in those avenues. So not every administrator, defender, or offensive practitioner knows everything. So like even I'm out looking at everybody else's blog posts, our competition, they're our friends too, right? Our competition and what they're making and things. And how can I make that better for me and my customers and clients? So take what we do, test it out in your environments, tune it, tweak it, learn. Join us here in Discord. It's a great place to be. a lot of you here. This is awesome to see. And people do research and stuff like that. They're always worried about like repercussions and things like that. I always like to just put on a friend of mine that I respect quite well. Be your best black hat, right? Do the things to the most malicious intent that you can do, and if you have to dial that down for public ingestion later, but that's where you really learn like the things that this has been working for years. How would a threat actor like repurpose this today with today's technology? So that's where I went with the SSH and that stuff's available on Windows now. So things change every day. Microsoft puts stuff. I mean, 2 years ago, they made business tenants in Azure default communicate with each other, and that was a terrible mistake. So things change all the time. Do your best to stay up with them. Lean on your friends in the business to keep you updated. You don't have to know everything. For me, it's about how to learn and research and take what you've gotten and put it into your own context. So keep learning, keep trying, keep breaking things. Hope you all enjoy the tool and the things that I write and get use out of it for you and your clients.
Well said. Well said. And with that, I think we'll wrap up a little early. Thank you guys so much for joining us, Black Hills Information Webcast. And we're here every Thursday, usually, if we're not traveling. And yeah, thanks so much for joining us. Ryan, you have one job. You just got to kill it.
Kill it. Thank you all.
Kill it. Kill it.